And now let us discuss the next theme of our lecture about the curved lines. Curved line can be represented like the direction of a movement of a point in space or on the plane. A curved line can also be obtained as a result of the intersection of a surface with the plane or two surfaces with each other. Curved lines can be flat. It means that all the points belong to the same plane. And curved lines can be spatial ones. Those points do not belong to the same plane. Examples of plane curves are circle, ellipse, parabola. An example of a spatial curve is a screw line. A line is considered natural if it is subject to some law in its formation. If at the same time a curve in the rectangular coordinate system is defined by the algebraic equation, then it is called algebraic. Examples of algebraic curves are a circle, an ellipse, a parabola, and a hyperbola. A curved line is defined by the positions of points from which this curve is consist. The points of the curve are defined by their coordinates in space. On this drawing, the curve is defined by its own projections. We have two projections of the curve, on the horizontal plane and on the frontal plane. To construct the curve projections, it is necessary to construct projections of the number of points belonging to the curve and connect them together in the same sequence in which they were located on the original. So we should project each point of this difficult curve from one projection plane to another projection plane, and only then connect all these points step by step. When you specify a curve by its projection, you must specify at least one projection of a point belonging to the curve. By drawing the curve in the general case without additional spatial constructions, to define it on flat. On this drawing, the curve, it is denoted like the curve A, small letter A, is special because it has competing points C and D. If the drawing does not understand whether the curve is flat or spatial, additional constructions are required. Now, let us talk how to construct the projection of flat curves. To depict the shape of a curved line more correctly, when constructing its projections, it is necessary, first of all, to construct the characteristic points of this curve. These points are the special points of the curve, as well as the points that are on the maximum distance from the projection plane and closest to the projection plane. In descriptive geometry, curved lines are studied from their projections on a complex drawing. On this drawing is shown point M, the capital letter M. We have two projection planes, horizontal projection plane and frontal projection plane. So on this drawing, point M represents a curved line that is obtained when the point M is moving. The position of a point is determined at any time by the movement of its two projections, M1 and M2. It means that the curve itself is defined by its two projections, the small letter M1 and the small letter M2. To construct such a curve, you should take a number of points on the line of the curved line, and with the help of communication lines, project each point from one projection plane to another projection plane. Only after this, we can connect all these points and get the form of our curved line. A point of curve is called ordinary if a single tangent can be drawn to the curve at this point. You can see this on our next drawing. On our drawing, such a point is the point M, the capital letter M. From the properties of parallel projection, below the properties of curved lines, which are stated in their projections. The first property: if the point M belongs to the curve, how it is shown on our drawing. So if the point belongs to the curve, then the projection of this point belongs to the projection of the curve. So if we place a point on the curved line, if you place a point on a curved line on one projection and our point belongs to this curved line, it means that it will be placed on the same curved line on another projection. The second property: the clipping plane and tangent to the curve of the line are projected respectively into the clipping plane and tangent to the projection of the curved line. And the third property: infinitely distant points are infinitely distant points of a curved line, for example, are projected to the infinitely distant points of its projections. And the last property: the order of a plane algebraic curve in parallel projection does not change. It means that the number of points of intersection of the curve and straight lines is saved. Preserving these properties of curves in parallel projection allows us to state that a circle and ellipse and that the circle and an ellipse are projected into an ellipse. A parabola is projected in parabola, and hyperbola is projected into hyperbola. The most common spatial curve in engineering practice is a cylindrical helical line. A cylindrical helical line represents the direction of movement of a point that performs a constant translational motion along the axis of a constantly rotating cylinder. The axis of cylinder will be the axis of the helix, and its radius will be the radius of the helix. So, on this drawing, you can see the construction of this helical line. You know what is it? Helical line in engineering graphics, it's a screw line. We construct, we cut the thread on our cylinder rod with the help of this helical line. So, how can we construct this line? On our left drawing, you can see two views. The circle on the horizontal projecting planes and rectangular on the frontal projecting planes. It's two views of a cylinder. To construct this cylindrical helical line, we should make some steps. First of all, on horizontal plane, you need to divide the circle on 12 equal parts. The beginning of our construction is point A. It is placed at the left on the horizontal line. So, on our horizontal plane, we get the circle with 12 equal segments. Now, we have the height of cylinder. If we want to construct not one but two or more spirals of helical line on our front view or on our frontal projection plane, for this, for example, on our object we have two spirals. For this, we need to divide the height of our object on the front view, on the frontal projection plane, on two parts. It means that we will get two spirals of the helical line. Each part you should divide on 12 equal with each other parts. The height you should divide on 12 equal with each other parts. And through these parts, you need to construct horizontal level lines. Now, we need to project each point from the horizontal projection plane on the frontal projection plane. So our first point is point A. It is marked with number 0. This point is placed on the side of our cylinder, belongs to the vertical line. So we project point A on the bottom base of cylinder on the side, on the left side of our cylinder. The next, our horizontal line, level 1, means that we should project point number 1 from the horizontal projection planes, and this point is located on our circle on this level. The next level, number 2, we take the point number 2 on the circle on the horizontal projection plane and project this point number 2 on the frontal projection plane on the same horizontally level line. So we can step by step we project all the lines on our frontal projection plane. The point number 6 also is located on the horizontal line. It means that this point belongs to the vertical side of cylinder. And you can see from the drawing that, of course, it is placed on the vertical line, right side of cylinder. Step by step, we constructed the lines, and these lines on the frontal projection planes, we can connect and get a cylindrical helical line. It's not difficult, as you see. You only must be very attentive constructing these lines. We use the level lines. About these lines, we talked with you at the beginning of our lecture. And with the help of this cylindrical helical line, we can show the direction of motion in the thread. So the form of the thread will be a cylindrical helical line. A curved line can also be represented as the intersection of two projecting surfaces, as it is shown on our drawing. We have a curved line, and with the help of the communication lines, projected the points of the curved line on the frontal and horizontal planes. So, today I explained you different curved lines and different methods of the constructions of these lines. I hope it was interesting for you. And now our lecture is over. Goodbye.